Okay, so here's the deal. So everybody knows we're in a climate emergency. Everybody knows that we're going to 5 and 6 sigma deviations. And the question is, what are we going to do about it? And this is especially important because at this stage, we're not talking 1.5 degrees. We're not talking 2 degrees. We're talking 6 to 8 degrees that's already put in there. That's if we stop emitting today. And the consequence of that is an extinction level event. And what we are doing is necessary but not sufficient. We do have to lower emissions by 50% in the next 6 years. We do have to get them to zero. We are going to get there because the cost of electricity and the cost of wind and the cost of other technologies is coming down so fast that we will actually be able to do that. The question is, how do we bridge the next 10 or 20 years? And that's the real question. And there we've got to think big. And the argument that I'd like to make today is we are asking engineers to do the wrong thing. Because if you ask an engineer to build a tent, they will build you a beautiful tent. If you ask an engineer to build you a house, the materials will be different, the scale will be different. If you ask an engineer to build you a city, they will do something very different. What we are asking engineers to do is to lower emissions by 50%. Again, necessary but not sufficient. We have to think at a completely different scale. The scale we have to think at is how do you lower the temperature of the planet by 1 to 2 degrees centigrade. And what I want is I want the entrance to Davos, I want the entrance to COP, I want the entrance to the UN, I want the cover of Science, Nature, PNAS, and every report to have minus 1 degree centigrade. Because we have baked in so much heat into the oceans that if we quit emitting, we will still heat. And as we're going through this, that involves physics. So there's 3 ways to cool the planet. All of them involve having less energy hit the Earth from the sun. So what you're trying to do is you're trying to take these little packets of energy, the photons, and make sure some of them get reflected or don't hit the Earth. 3 ways to do that. The first is find a Lagrange point where the orbit of the sun and the orbit of the Earth are aligned enough that if you put up a big space blanket, you're going to create a partial eclipse, which hopefully will be across the Arctic or the Antarctic. Because you have to refreeze those 2 things if you don't want to lose all of your coastal cities, and you don't have a lot of time to do it. The second thing you can do is to put stuff into the stratosphere. And what I want you to understand here is just how damn thin the stratosphere is. So if you take an apple, and that is the Earth, the stratosphere is the skin on that apple. That's what you're talking about. Now, why do we think this is a feasible strategy? Because when Mount Pinatubo erupted, it actually lowered the temperature of the Earth, depending on where you were, by 0.2 to 0.7. That's a single volcano. So this can be done. It can be done at scale. You do not want to do it with volcanic ash. And the reason you don't want to do that is because that eliminates the ozone layer. So what we have to start doing is we have to start thinking what chemicals are not going to destroy the ozone layer, the stratosphere, not fall to Earth and harm stuff, and we have 2 years to do that. Because we also have to build the balloons to get this stuff up there, because there are only 4 civilian airplanes in the United States that can fly in the stratosphere. This is what you could do in terms of marine cloud brightening. So the third strategy you can use, space, stratosphere, Earth, is to create a very fine set of mists to brighten the clouds and have the same effect as fog banks. And there are a series of marine cloud projects, but these have to be funded at scale. They have to be done with autonomous boats. They have to be done with the right energy mass balance. So we do not have a lot of time to do this, because this is working on an exponential structure. And the energy imbalance, how much energy is coming in, how much energy is coming out, has increased 2x in 20 years. And what that means is we're heating, and we're heating, and we're heating, and we're doing so at a faster rate. And that's an extinction level event if we don't intervene now. So what is the action idea on this? We need to test hundreds of materials in the stratosphere, and we need to do it right now. We need to focus on the Arctic, Antarctic, and permafrost cooling. The permafrost cooling is especially important because of the methane releases. Methane is 89 times more potent short-term than CO2. And if the permafrost goes, all that methane is going to come out. We have to test balloon trajectories and dispersal and build to scale. We need to test rapid autonomous marine cloud brightening. We need a rocket consortium to test a space blanket. And we need to begin an orderly retreat from the coasts and the lowlands and lower the dam temperature. Thank you very much.